This session is Virtual Desktop Scare Me. We have presenter Stephen Hunt, who is Director of Information Technology at Queen's University. Stephen?
Thank you. And Graydon Smith, my systems guy who knows all the technical details. And I should point out that I'm the Director of Information Technology for the Faculty of Engineering at Queen's University. It upsets our CIO when I don't make that condition. So anyway, thank you, and thank you for coming. It might get a little warm in here, but we'll see how we go. So the first thing, I'm going to get a little audience feedback from you. Okay, and this is kind of neat because it's live. So if you're on that web page, you should now have a question in front of you. Go ahead and answer it. Ooh, look. I hope there aren't more than 40 people because I only have the free account. Oh, that's kind of neat. Okay, yeah, lots of people doing stuff with virtual. Okay, so you can see we've got lots of people doing stuff with virtual desktops at this point. The word virtual is almost becoming a cloud. I'm scared to keep using it very much. A few answers still coming in there. All right, so overwhelmingly people are starting to move in this direction is clearly the answer to that one. So here's the second question. What's your level of expertise around this stuff? Okay, that's great. Well, that'll help us sort of gauge the presentation around a little bit. So some of you are new to this. You have been doing a lot. Excellent. Okay. Well, this is primarily a story of our journey with virtual desktops in the Faculty of Engineering at Queen's, and sort of how the thing has gone and where we are and where we're heading in the next little while. So the first question you have to ask about all this, of course, is why are you doing it? Here's some of the things that virtual desktops are supposed to be able to deliver to you. Okay. It's supposed to simplify your infrastructure. It takes a whole lot of stuff and puts it all back in the server room. It brings thousands of things down to a much smaller number of things. You can respond more quickly when you need changes. You need to add, you need to delete, you need to change. It's very scalable. If you've done the setup prop at the beginning and need more storage, slap more storage in. It doesn't affect anybody. Everybody can continue working while you're doing all this stuff in the back end. It's fantastic. It's reliable because you've taken all those spinning hard drives and all those power supplies, for the most part, and you've put them in a server room where they're properly air-conditioned, and you've put RAID around them and all those kind of good things. You've moved all the data from those spinning hard drives on the desktops back to, again, your server room with the big lock on the door and the alarm system. You can lower your total cost of ownership, in theory, because, for one thing, you're reducing your support load quite a lot. Okay, and because we're using a much smaller amount of equipment to serve a larger number of people, so we're sharing, right? It's the value of the sharing. Significantly lower power and cooling usage, particularly in your labs, becomes very significant. Again, Michael at McMaster did some actual numbers around this, and I think he recorded something like $20,000 or $25,000 a year in air conditioning reduction in this one room that they took all these computers out of. In fact, interesting story, one of their drivers for putting in VDI at McMaster was that they built this room and then discovered that the air conditioning wasn't sufficient to handle the 45 computers that were going to go in there. So they had a choice between boost the air conditioning, very expensive, or do something else with the computers. And that was one of the drivers for them to look at virtual desktops and move ahead with their. This one should make you skeptical immediately. It isn't very fast all the time with everything, but I think what we can say is it's much more reliably fast. Once things are up and running, it's very consistent, okay? We're moving a lot of the resources back next to each other. So for example, your desktops are now literally sitting next to the file server in the server room. Okay, so all that movement of traffic that students are doing, saving their files, is from one device to another, probably on a private network, very high-speed private network in your server room. It's not hauling across the campus core. So we're also going to highly optimize the Windows 7, assuming you're running Windows 7 or whatever operating system. We strip out all the stuff that's not necessary. Okay, so you do gain a lot of optimization to make things move more quickly. We can get to it and to those desktops anytime, anywhere, anyhow. Okay, so students can get to their desktops from an iDevice, from a laptop, from their dorm, from their house. They can come into your labs. They can be out in the field. We've had a lot of good response from students doing field work, civil engineering students being out doing field work and be able to pull up their desktop and put stuff right into their spreadsheet while they're there. They like that a lot. And I'll talk a bit more about the remote piece later. And fast recovery. Literally, you remember you used to say, if there's any problem with your computer, we're just going to bring a CD along and we're going to blast away your C drive and rebuild the operating system. But you could never really do it because people always had their music collection on there or their whatever they had. Well, with virtual desktops, you literally do, okay? We remove the persistent disk, we build them a whole new operating system, we put it back on, it takes about 3 minutes, okay? So we can do it very quickly. And in fact, leads me to an interesting thing. Years before I did virtual desktops, I was down in Miami for a conference, and in the Miami downtown core, they have these parking meters all over the place. And if you look closely at the sticker on the parking meter, it says, if this machine malfunctions, use another one. And I thought, this is the model for technical support we want, right? Don't call us, just go use another one. And with virtual desktops, we've kind of achieved that because literally if there's anything wrong, student can go and log in at a different machine and they'll actually get a whole new desktop, okay? And that happens pretty much automatically, okay? So one more question for you. Still got your laptop, still got your devices out? Of those things that I've mentioned so far, in your environment, what do you think is your biggest problem? Desktop support, the cost of replacing all those physical machines all the time, heat and power usage, yes, I should have had an all of the above. Pick one. I'm making you put a priority on things. Yeah, that's kind of what I expected. I figured that's probably where we'd end up. So responding to requests from instructors rapidly, and we'll talk a bit more on that in a bit, and the cost of and of course the cost of doing all this evergreening, this lab replacement isn't just the hardware, it's the time, right, spent. Okay, excellent. So the next thing we did, we kind of identified that we would like to do this, and we would go ahead. We started doing a little bit of planning. So what were our goals? What did we want to achieve to this? Well, this was a big one. The disk imaging cycle of pain that you're all no doubt familiar with. You know, at some point in July, you ask the instructors to please let you know what they need on the disk for September. You give them a deadline, which none of them meet, or 25% of them meet. And then you start to build the image, you discover that there are conflicts between the software, that one of them has a piece of software that needs this SQL driver, and another one has a piece of software that needs a slightly different version of the SQL driver. You finally back this thing together into this rather massive several hundred gigabyte disk image because you've got software coming in from all over the place for this shared facility. You begin disk imaging it, pushing it out with Ghost, and as soon as you start doing that, someone walks in the door and says, ooh, I forgot. And you start this whole thing over again. And these images are getting to be extremely large. The software keeps getting bigger. So, and then in the middle of the term, you have instructors coming along saying, hey, I've got this cool idea. And we love cool ideas. We'd like to be able to respond to them. But in the past, we've tried to do that. We've broken the image for someone else, right? So we've mucked up some other instructor's class by trying to be helpful. And there's all that imaging time using Ghost or whatever piece of technology you're using to try to push things out to all those hard drives. Another thing we wanted to achieve was that we had computers all over the place. There were different kinds. They all had different drivers. Even within the same models, they had different drivers because we bought the consumer level ones and not the corporate level ones. And we really wanted to try to reduce the support load on all this stuff. Okay. So life cycle costs, again, a lot of support, a lot of labor hours involved in this. not to mention all that hardware. The at-desk support load, too much time having warm bodies sitting at desks with screwdrivers, pulling out dead hard drives and replacing power supplies. And of course, mobile access. Going back to the at-desk support load, we actually had a funny experience with this, which is that one of my staff used to spend a lot of time in one of these computer labs. He now spends so little time in the lab that we've actually had to sort of do a deal with the cleaning staff to please let us know if someone spills a Coke on one of the keyboards. Not that students ever do that. But we literally spend so little time in the lab that we're not aware sometimes. And as you all know, students, of course, tell us all these things instantly. But at the same time, I was scared to move forward with this thing. I mean, it all sounded wonderful, but we're an engineering faculty. We run some very high-end CAD and 3D design and software like that. It needed to work. It needed to be at least as good as it was the year before. There's certainly this thing would be a complete failure if students came back and said, it's crud compared to the computers we had before. It needed to be highly reliable, and it couldn't be affected by crunch times, the times when 40 students log out, the next 40 students log in 10 minutes later. We needed it to move through those things again without someone saying, oh yeah, it's slow because it's this VDI thing, right? That wouldn't have been a good thing. So we paired up with Teramac Technologies here in Ottawa. They had done some work for Algonquin College, and we had them come in and work with us on setting this thing up using their expertise. One of the first things they did was to bring in a piece of software, load it onto our existing physical machines in the labs, and let it run for a little while, and it just watched what was going on in those machines. So we could sort of see what the students were doing and when they were doing it. So this is one of the reports we got back. This is the indication for the machines, a little bit cut off at the bottom so you can't see that. But this is what came back from the machines they were looking at. And about a quarter of them came out good. And about 3/4 came out fair. There were no poors, and they're all kind of in the upper right quadrant. So I sort of went, nah, okay, that's not too bad. And then we looked at the students. So the last one was the machines. This is the actual users. And again, similar, a bunch of goods, a big bunch of fairs. And in this case, we had a couple of poors. Still, upper half. So I thought, well, it's not too bad, but it's not really great. Like, it's not like a slam dunk here or anything. And then we dug into this a little further, and we figured out what exactly it was that the students were doing on the computers. And so this was revealing because, of course, what they were doing is they were coming in at night with a CD, they were dropping into the tray, and they were running all these massive multiplayer games, right? The only legitimate thing on this entire list is this Quartus. And of course, that's only the bottom part of the list, but those were the worst. For players, and that was for CPU cycles, and this is for memory. So again, you can see part of what you have to look at when you get these kind of assessments is, are we really assessing the right thing, right? So if we want to put in a virtual desktop for them to play Half-Life, probably not a good idea. If that's what you want your students to be doing, it may not be the right solution for you. But if you look at the software that you actually want them to run, it's a lot better. Another thing you have to think about is anti-malware. In the past, with physical computers, we tend to have a copy of Symantec or whatever running on each local machine. That you can't do that in a virtual environment. Well, you can if you want to make sure it doesn't work very well. Because, of course, you're wasting a lot of cycles, right? All the CPUs doing all the same thing, all downloading virus images, all scanning all the same stuff. It's a waste. So fortunately, VMware in View built a hook into the system so that clever software people could, in fact, get in there and scan files for the whole system as they're going by. And one product that does that, the one we ended up choosing, Trend Micro's Deep Security product. There are a couple of others now as well. And they do the same thing. They use the API so they can dig in. And so you set up a number of virtual servers running this product, and they do all the anti-malware for all the virtual desktops. So you're not running it separately on the virtual desktops. However, we discovered, this works fantastic, by the way. We're very happy with Trend Micro's solution. But as you can't neglect it as your system grows. Because one thing we discovered is that those virtual servers that are doing all that become a bottleneck. You have to be very careful with them. We had some odd behavior, and it was not immediately apparent that it was related to this. One was we had a secretarial assistant, who called us and said she couldn't put a PDF into an email. Okay, so we went down and had a look, and sure enough, she was dragging a PDF from her desktop onto an Outlook message, and the message was popping up saying, this file is open in another application. She didn't have an Acrobat Reader open, it wasn't being shared by someone else. It turned out that we had let these servers get just slow enough that in the process of dragging it over, the trend was trying to scan the file, and it was leaving it open just a little bit too long, and Outlook was saying, oh, can't use it. We fixed it very quickly once we knew what the answer was, but it's that kind of slightly odd behavior, right, that you might not think about. So when you do the anti-malware, you do have to monitor. I'll keep coming back to the monitoring thing a little bit later on. Another thing for us, and I would say for pretty much any deployment, this would be my recommendation, PCOIP is pretty essential. For those who don't know, this is a communications protocol that takes all the video, the keyboard, the mouse, and the USB traffic from those 0 clients to the server, embeds it all into a single network stream, compresses it so it's faster, and encrypts it so that it's secure. And because of that encryption, you can run PCOIP across unprotected lines. You don't have to worry about encrypting it later when you get to the remote part. The compression is essential for graphics. I mean, who cares about the keyboard and the mouse? But the graphics and the 3D drawing and all that kind of stuff that our students were doing, PCOIP is essential to make that work successfully. And you really want to use 0 clients. These are the ones we use, the WISE P25s. They have embedded PCOIP hardware. So all that decrypting part at the end is being handled by a dedicated piece of hardware. Yes, the whole thing works fine. If you, sorry, let me jump back one. You can use your laptop to get in. You can use your iPad to get in, and we have lots of people doing that. And students can use their own laptops from remote. And again, for most applications, that will be fine. But when you're running AutoCAD or some other big, heavy design thing, this piece becomes very important. And if you really want the thing to perform in your labs the way the labs did before, this is important, okay? Using the PCOIP. So I'm going to let Graydon describe a little bit about sort of the back-end hardware that we ended up with.
So basically, in our area, working with our vendor, we came up with a solution that relies upon an EMC VNX 5100 SAN that we divided into 2 segments. So we have a virtual server environment component. This handles all the vCenter and all of the connection brokers and security servers. And then we also have the host, which just handle the desktops. Now, for the servers, we didn't need a lot of performance, so we just stuck with some 7,200 RPM, 2 terabyte disks, separate bus, and just carved it out in a large RAID array. And that pretty much is our virtual server environment. But for the VDI, we stuck with 50K RPM, 300 gigabyte SAS drives, and we put them in a RAID 0+1 and carved them out into 500 gigabyte LUNs so that we could get, when we do our replica clones, you basically create one master image and it goes off on one LUN, and then you get link clones. So only the changes that happen for the users when a new desktop comes up stick on the other LUN. So we spread it across a variety of spindles, and it really helps with the performance and the recreation.
Excuse the interruption, everyone. We have a special guest here who would just like to come say hi to all the Cat High guests.
Okay. My goodness, who's here? Woo! He's down there. Okay, anyways. You want to have a good look at me? Okay, have a look at me. Look away, baby. I don't see the back too. There we go. What do we got on the board here, man? Just when I was in high school, we didn't. What the heck is that? That's what the women in cars, man. That was it, Anyways, just everybody asked me, "Oh, Elvis, do you miss performing?" Not really. Shaking and wiggling is pretty damn hard work, I'll tell you. Ain't as young as I used to be. So anyway, listen, you're a good crowd. You look like a great crowd. Let's show the ladies. Hello, ladies. How you doing? So listen, it's wonderful to be here in Ottawa, even though it's raining. Kentucky rain, whatever. So until we meet again, may God bless you and adios.
I believe that was an example of a virtual person.
Okay, so where was I? All right, so we're talking about lunge. Basically, you carve it up like you would a database system, right? You want to make sure you have a lot of spindles, throw as many spindles at it as you can. You know, standard disk. For the hosts, we settled on Cisco UCS 50. The reason why we chose the Ciscos was because the RAM speeds, when you get high density RAM in the Ciscos, they, according to Cisco, they don't suffer the same memory speed degradation that other hosts get and other servers, at least at the time. A lot of other manufacturers, they brought it up finally, but at the time Cisco was the only one that could do it. Looks like we have a typo here. For the host, we jammed them full of 192 gigs of RAM and 96 gigs of RAM on the virtual servers. And it's just standard ESX. The key component to this whole thing, though, is we went with the Cisco converged networking. All right. So out of the back of each of the hosts, does anybody know about the Cisco converged networking? Anybody had any experience with it? Basically, Cisco drives everything down 2 wires out of the back of the server. So you can carve out up to 120 virtual network interface cards in each of the server. So you only have 2 wires coming out. They're 10 gigabit per second, twisted copper. We run our fiber channel over Ethernet to the SAN down the same line as our regular network. And so the wiring and the cabling for the servers is really, really simple and really clean. And any flexibility we wanted to make to our network changes. So we want to put in a whole new network, a new VLAN. You just go on the server, virtually add new NICs, and there you go. You have a whole new network right there, all virtually carve it out on the Nexus switches. Everything's peer linked. All of your transfers from your hosts are going at 10 gigabits per second. vMotions are really, really fast. It's really impressive. So that was really the key to make this work, is because all of our transfers and all of our performance problems that you would normally have, all the traffic stays in here. The only traffic we get coming out of the Nexus is anything that's outside of our environment, the internet, and PCIP traffic. So everything stays internal to our whole environment.
Great, thank you. Okay, so in the end, these were the cost factors we had to look at to put this in. The servers you saw, the C250s, the VNX storage, the Nexus switching, the Zero clients themselves on the desktops, and then 3 pieces of software that you need to think about. VMware ESX, which of course runs the servers. You probably already have it if you have any kind of virtualization of servers. VMware View, now called Horizon View, which handles all those individual desktops and the spinning up and the creation and the deletion of all those desktops. And your anti-malware solution, Trend Micro in our case, and then what you're going to pay your partner to help you put this thing together. So that in the end was the different costs we were looking at. So then we took this thing into production. Oh, and you can't see the punchline on the joke. It got cut off at the bottom. It says, "I don't always test my code, but when I do it in production." So in September 2011, we did 2 walk-in labs. Now, walk-in labs meaning labs that students are just going into and working randomly. Much easier than teaching facilities because, again, they come in and out on essentially a random basis, right? So that was how we started with. It worked really well, so we began converting some offices, administrative offices, starting in January of that year. Last summer, we actually did 2 classroom facilities, again, where everyone's walking in at the same time, sitting down, logging in. And another lab, which was rather remote on the campus to show that in fact, we found that the networking would be fine. And then this summer, we're going into another walk-in lab, also kind of remote, and we're continuing to move across our offices. So as people in offices, their computers reach sort of 3 or 4 years, we're just giving them a thin client now. After we had it running for a little while, we wanted to get some feedback from the students. So one of the things we did was we sent out a survey around Christmas of that first year. And the survey was sort of like kind of how do you compare this to the machines that were here before? So we wanted to ask the students who had been at the university the year before. And for the most part, the answer we got was meh, which is kind of the answer we wanted. It's fine. It works exactly the same way as it did before. Yes, it's a computer. It's Windows 7. It runs. It does what I need it to do. It didn't really impact them, which was great because the benefits to us were primarily on the back end in terms of the support and the maintenance. We didn't really expect the students to go, whoa, because you know how easy it is to impress students. We were happy with them saying this is great. one of the things that came out of this, because we left a little bit of an area for them to talk about the things they liked and didn't like, is we had this funny result, which was that the one thing they really liked was the ability to log off, go to another station, and log back on again. We thought, well, this is very, and get the same desktop. And so I have to explain a little bit. Normally in the virtual, when a student logs off, his desktop is actually deleted, and so that every student logging in gets a completely fresh Windows 7 install back to scratch. It's kind of like we use deep freeze, something like that on your physical computer. But we had set it so that I think within 3 or 4 minutes, if they logged back on, they would get the same desktop they had before. We hadn't deleted it yet. We couldn't figure out why they liked this, right? And then we figured out it was what we started calling the pretty girl effect. You're sitting in the lab working, and a pretty girl walks in. And remember, this is engineering, so there's not that many pretty girls. I'm sorry, there's not that many girls, let me qualify that. I mean, we actually have more females in our program than any other engineering school in Canada, but still, it's only about a quarter. So pretty girl walks in, so you log off, and you slide over a little closer, and you log back on again. And we figured that was what the effect, why they seemed to like this so much, was the pretty girl effect. So we got some interesting, and most of the things that they told us in that survey, we were able to fix very quickly. They were minor correction problems. We also set up an online forum. So the hope was that students would go in if they did encounter a problem and let us know about it right away, rather than 3 months later or 6 months later ask them in a survey. Boy, it's hard to get them to provide feedback. Despite this and sort of promoting it, putting up the labs, a number of students joined it. We did hear about a couple of things, but we still don't get as much back as we wish we could get. So we're still sort of working on that. Probably the most successful is I do go to a number of departmental computing committee meetings, which usually have students with them. And we've also had students come to us and basically do some data collection for us, which has been great. And again, as you know, when things are brought to you, you can fix them. Right? It's when you don't hear about them, it's the problem. And all of these things are correctable without too much problem. Once we were in production, we wanted to make sure that we were monitoring what was going on. And we basically used 4 different types of service. Basic system monitoring that you would already have. We use Nagios for basically seeing that things are running, getting notified when they aren't. We use a product to monitor the virtual system called SolarWinds Virtualization Manager. There's at least a couple of others. VMware's vCenter Operations Server is available. And another one we looked at, his name escapes me right now. Stratusphere UX, which monitors the end user experience. And I'll show you some examples of what you get back from that in a second. And then, of course, the trend anti-malware. So these are the kind of things that Graydon keeps his eye on a regular basis as the system is in production. So Nagios, as most of you know, this is one of our vCenter servers. I just grabbed a screen grab. Is the C drive running into space? What's our ping response time? Is it quick? What's the load on the CPU? Things like that, right? Basic system monitoring. Graydon's going to talk a little bit about some of the screens that we got from SolarWinds here and just explain what's going on.
Now, I mean, with our host monitoring, we treat every single guest VM in the virtual environment, not counting the desktops, but every server that monitors it, we monitor the availability and its performance in Nagios, but we don't get a lot of data around what's happening with the data stores, what's happening with the performance of the ESX, what's happening with the performance of the VDI environment. So we settled on SolarWinds for this because SolarWinds gives us at a glance a lot of the data that we're looking for. Now in this particular case, out of the 6 hosts that we have, we're showing 3 warnings here. And I do believe at the time this snapshot was taken, this was a class change. So we saw a little bit of the data store latency issue. It was very minor, but we could pick it up. And so some of the virtual machines, which ones are those anyway? We don't have the.
Probably can't read it.
Can't really read it, but most of those, most of those VMs, we can actually see at a glance which of the virtual desktops are having issues. The challenge that we have with SolarWinds, though, is that some of these alerts are false positives because you get a little bit of a spike every time you go through a refresh. So when a desktop is deleted and a new one's created, you get a tiny spike in the CPU usage, you get a tiny spike in memory usage, and SolarWinds will alert you on that. So when it comes to our alerting, we had to be a little creative to filter out some of that. But at a glance, we get reports of what goes on. So in this particular case, this one is for, the host CPU usage from March to May. So as you can see here, so this is the number of VMs by cluster. And so it just basically shows how many VMs we have running at any given
You can see
time.
where the term ended.
Yeah.
Fairly clearly.
Yeah, right there. And so that's the number of VMs we had actually running at any given time. So we always have a bunch of spare VMs spun up and running in the background. So at that particular point, the scale on that is at one point we had 300 VMs spun up.
Something like that.
So, I mean, the system holds quite a bit. This one is the average host CPU usage. As you can see, it spikes up and down throughout the day. You can see the week and the weekends as time goes on. We get lots of good data. We can see that we spike out regularly at about 40% on our host CPU usage at any given time. So that's, that's pretty good. And that's usually, these ones are usually class changes. This is when we have 40 VMs, 40 students log off at once, and then they all get deleted and 40 new VMs get spun up. You get a big spike. But as it goes on, if you zoom in a little bit closer on it, which we don't have, unfortunately, you can see those little spikes, and then it levels out very well. And so again, this is the same sort of graph. This is average utilized cores, how many cores are actually being used at any given time, and we're up at about the 10.
That one's cores per VM. A lot of metrics come into this. People often say, how many servers do I need? How many CPUs do I need? How many? And the answer is always, it depends. And it depends on the kind of software you're running and the kind of things your students are doing. You can see that in this case, we're running around about, averaging about a half of 0.05 cores per VM. And again, one of the reasons for that is that in order to reduce those class change spikes, we do leave a lot of machines spun up in the background. So this looks better than it would be if those machines were all actually active at the same time. But we leave a whole bunch of machines just kind of sitting there humming away, waiting so that when students come in and go out, they're available for them quickly.
And again, now this graph here is total host memory usage. Now this shows both clusters, so our servers pretty steady, but as you can see the memory usage, there's the end of term, and then, that's when our outreach program started up again.
Right.
So it's, that's when the summer campers, EMCs, So you can, we get good trend as to memory usage. This is Stratusphere. Did you want to talk about Stratusphere, shall I?
Sure. This is that other product I talked about, Stratusphere, which monitors the user experience. That's what the UX stands for, user experience. So this is, again, kind of the dashboard you see, and I left it running for a short time. So for example, it says, what's the CPU queue depth? Doesn't know what that means. Login delay, there wasn't any at the time that I was watching it. But is anybody getting delayed in login because of virtual problems? This one was the user experience number, which is a rating that Stratusphere puts in there. And again, you don't need to know all this stuff just to see the kind of information that's available. If I left this running long enough, slowest application launches, we would have had some better data here. Office 2013 takes significantly longer to launch than Office 2010. Not sure why, but those ones often appear there. Application launch delay averaging about 4 seconds, so that wasn't too bad. So you can see the kind of information that you get, and these are all configurable dashboards. So this is the kind of stuff that you can sort of monitor as you're going along. Okay, and this is another Stratusphere report. Actually, this is just a list of the reports, and again, not to be exhaustive, but you can get a ton of stuff out of this. This is a virtual machine running in the background, monitoring the virtual system. Huge amount of information available to come out to get metrics out of and plan. So do I have any regrets for having done this? Well, unlike this guy, no, I think we're very happy with what we did. We're very happy with the performance of the system. It accomplished the goals we set out for it to accomplish. We certainly learned a few things along the way. This is the big one. Once you put in VDI, everything becomes a VDI problem. An otherwise intelligent man who works in our office came and said that he was having a VDI problem. It turns out that he had gunk stuck on the space bar of his keyboard. That was a VDI problem, because everything's a VDI problem. Normal Windows behavior suddenly becomes a VDI problem, not a Windows problem. So in the past, people said, oh, Windows 7. Now they go, it's that damn thing you put in. right? So it does become an interesting communications problem that you have to work with. People will talk about pilot phases. There really is no pilot phase. Once you put this thing in and it's operating people's desktops, you can't just go, decide not to use it anymore. It's in production. And we discovered this when we tried to do a major upgrade this summer after we put this thing in, and we broke several people's persistent disks in the process of doing that, and that was not good. Once you're in production, once you put this thing in, you're in production, right? You have to treat it as a production system. You can't keep sitting back going, well, it's just a pilot. I don't care, it's my desktop, right? It's not right for absolutely every situation, and it may not be right for your situation. We have a number of physical machines in one of our labs that we have chosen, at least for this summer, not to convert because of mostly a human issue. The guy who's in charge of the area is going to be on parental leave for 3 months, so we're not going to throw a new thing in there when he's heading out. So, sometimes you have to think about particular issues. Software licensing, I'm not even going to start on this because it's been talked about in a lot of other sessions, except to say that my opinion is that it's our responsibility collectively to be pushing the software publishers a bit, okay? We're not going to support it because it's running in a virtual environment thing is a cop-out. You need to learn to support it. This is 2013. Everybody's doing this in some way or another. We need to all be pushing. So there's my sermon for today. Microsoft has a habit of just kind of changing the rules periodically when they feel like they need to put their profit margin up. We got to be pushing back a little bit and saying we need solutions that let us run this stuff remotely, thin clients, virtual machines, right? We're doing our best here. But it does get a little bit, you have to dig into your licensing. The best stuff is things like MATLAB that run on a back-end license server, because it doesn't matter where you put it, right? You're monitoring it with the license server. Those are certainly our favorites. Streaming apps, I won't really talk about that. Existing relationships, you do have to be very careful about change management. If you have technicians who are running Windows 7 right now, they can continue running Windows 7 and being responsible for desktops just the way they were before, but they're just doing it in a different way. They're not sitting in the lab with screwdrivers as much. They're back at their desks, deploying applications, setting up images, pushing things out, changing permissions and security. Okay, so you do need to sort of think through the change management and how it's going to affect your people at the end. You can do it yourself, but you really want to. We were very happy with our partnership relationship with Teramac on this. It worked very well for us. They brought a lot of good stuff to the table, put it in, transferred knowledge to us, and we sort of ran with it after that. So I would encourage you to do that. Converged networking, Graydon talked about, it's been huge. The fact that everything's going down that one pipe in the server room, we keep all this traffic local as much as possible. Because you do have to work with your campus networks group. That PCO-IP traffic does not need a lot of bandwidth. What it needs is consistency. So the holy grail for us would be quality of service on that PCO-IP traffic. We don't have it at Queen's yet. Queen's Campus Networks is in the middle of rebuilding a lot of parts of the back-end network, and I keep bugging them, and they keep saying, yeah, we'll get to that, we'll get to that. And I think they will. And in fact, it's working fine without it. But if you could do something, and if you have a VoIP system that you already have QoS on that VoIP traffic, because the voice traffic has to be real time. If you could get QoS on that PCO-IP traffic, even for just a little bit, even full screen video does not need a huge amount of traffic over PCI-IP because of the compression. But if it isn't consistent, the system is laggy. Okay, the cursor doesn't follow the mouse quite fast enough. And that drives people a little bit crazy. And dealing with the pools, I said we left all these machines spun up, ready for classes. That kind of thing is more art than science, and you kind of work it out as you go along, and you tweak. It's not something that someone's going to necessarily be able to teach you. And lastly, I would just say beware the hype. It isn't necessarily the right solution for everything, but it's worked really well for us. But you do need to see, is it better than what you have now? What are you going to get from it? Okay, what are we doing next? We're putting in some the product VMware has right now called Personas, which lets students' private information follow them around. Things like all their bookmarks and how they customize Microsoft Office and all that kind of stuff. It's Windows roaming profiles at a VMware level, which is great. We're looking at a product that will offload some of the graphics. Again, profs wanted full screen YouTube. That's a little rough in a VDI environment. The Apex card actually makes it possible, offloads the graphical processing from the CPU, from the host in the CPU. NVIDIA now has a card that can go into your host servers that can actually be dedicated as well, which we're looking at. And we're doing some things of looking at some of the applications that really need a lot of resources, putting them in some specialized pool that we can throw. And this is the neat thing about it. From the same box, a student can run a pool that has 2 CPUs and 12 gigs of memory, and then log in on the same machine a second later and have 1 CPU and 2 gigs of memory. So you can tweak all this stuff depending on what your needs are. You don't have to throw the maximum amount in every box because someday someone might need it. Okay, so it's kind of neat. And so one last question while we start taking some questions. One last question from me while I take some questions from you. If you aren't using virtual desktops in your area now, how likely are you to start?
While everybody's filling that out, can we go to the Q&A?
Yeah, please. I'm just going to leave this one up, so we don't want to go too long.
So questions from online are how many VMs do you run per host?
How many VMs do it? Well, if you want to talk the whole host, we have 3 hosts, and we were running about 300 VMs.
So we get anywhere from, it depends, right? The answer, maximum, I think we go about 120 VMs per host, but on average, we do about 80 to 90 VMs per host. Most of those, again, are sitting idle. So active VMs, about half of them, so 40, 45 are active at any given time. So.
All right. Second question we have is, do you want to deliver to BYODs?
Yes. We don't have a plan in place to officially abandon computer labs. Again, as I talked about earlier, those hardware Thin Zero clients can do a much better job with the graphics. So we really, and also Queens isn't prepared to say to every student, you have to bring a laptop. We want to have some facilities that everybody can come in and use, but there's certainly pressure from students to want to be able to do more with their laptops, and this allows them to do it. They get in, they see exactly the same desktop they would if they were sitting in the lab. In fact, a lot of them sit in the lab with their laptop and just use that, right? So because, it's their laptop, right? So.
I'm trying to get to another quick one. How many unused VMs do you have booted at any time for the walk-in labs?
It depends on the lab. We have the teaching studio in Beamish Monroe Hall, which is a main teaching lecture, and we usually have 80 VMs ready for that one.
45 seats, and we leave about 80.
We leave about 80 spun up, yeah. But that is the same pool. Yeah, that's one of the things about VDI is you actually have to stop thinking about it as labs now, because the desktop follows them wherever they go. So you can't think of it as, well, we're going to put this piece of software in this room because it's now available everywhere there's a thin client. So you have to say, well, I've got 40 VMs that I'm going to have to spin up here. It has to tolerate the changeover of 40. At the same time, we're tolerating the walk-ins over in chemical engineering. So we get some statistics on that. We find out that we get on average 5 logons or 6 logons an hour, except when they're running a tutorial. We had an incident where they ran a tutorial at exactly the same time. There was a class change in the teaching studio, and we ended up with a 90 login storm, which was it was an interesting. That was where we had to go and tweak the pools. Again, it comes down to the science and the scheduling. This tutorial wasn't really communicated that it was going to happen in the room, so we didn't know that it was going to happen until after the fact. We got the alert, we got the load, but so it's a hard answer. It's a hard question to answer. So
the nice thing is you can leave all those unused VMs sitting there, and they're using up effectively no resources, practically no resources. So you can have lots of them kind of ready to go.
All right. One more question, I guess. How many gold image do you have? Do you use any tools for image management?
We use the VMware tools. We haven't used anything else particularly for image management. Except what's built into the vCenter.
Yeah, so basically we create a master template, and then we clone that off, and we'll customize that for the pools, for individual pools. Some departments have their own pool. So electrical and computer engineering, for example, has their own pool that they create and manage their own software on. That's part of what we're looking at this summer. Is some of the students complain, well, we have 4 different pools, which one do we choose from? Or I'm running a piece of software here, I want to log in, but I now want to use this piece of software. I have to log out and log back into a different one. It gets painful. So we run from one golden master, and each technician basically customizes the images needed for each pool. So,
Any questions in the room? Yes.
Was there any software applications that you weren't able to support using VDI?
There are software applications that we weren't able to support. There's one we found that is a mining simulation program for our Department of Mining Engineering, which specifically in its software requirements requires a graphics card, which is very high end. And we can't provide virtually, at least not at the moment. That's the only one we found that we actually can't do so far, but you will encounter those. And it's another one of those, we won't support this in a virtual environment once. So there isn't much we can do about that, because if it didn't work, we wouldn't have any support. Yes?
Have you considered using it in exams?
The question was, have you considered using this in an exam? Yes, actually we have. In our first year engineering program, we have common first year, APSC 100. The students have to go and use MATLAB to analyze some data. And it actually made the exam process beautiful, because you can lock down the image really tightly. And so they can't get anywhere. And you can only restrict access to the pool on given times and to different groups of students. It really made the exam process very fluid and very, it worked really well.
It did, yeah.
It was great, because we actually had a makeup exam just a couple weeks ago. And so you just reactivate the pool, and there you go. You had the 3 students that were supposed to do the makeup exam, and they were able to do the makeup exam on laptops in a controlled room. So.
Thank you very much.
Okay, thank you.